Okay, so let's start off with a review of the product rule. So the product rule that we saw last time was the derivative, the dx of a function u and v. And that equals u times the derivative of v, which we call v prime, plus v times the derivative of u. And in practice, we can try it with actual functions for u and v. So let's do the derivative of sine of x times, we'll do x cubed. So to follow this rule, our u is going to be sine of x, and our v is going to be x cubed. So the derivative will be the first part, u, so just sine of x, times the derivative of v, or v prime. So this is our v. The derivative of x cubed, as we know from previously, you bring down the 3, so you get 3x. And then you subtract 1 from the exponent, so you get 3x squared. So the next part is times 3x squared plus v, so x cubed was our v, times the derivative of sine of x. And the derivative of sine of x is cosine of x. If we really wanted to, we could factor this a little bit further and take x squared out of each side, because we see there's an x squared here, there's an x cubed here. So to really simplify this, and let me get this away. To really simplify this, we could say this is x squared times sine of x times 3x. Just times 3. So really the 3 would go in the front. So 3 sine of x plus x cosine of x. Alright, and now we are going to introduce the quotient rule. So similar to multiplication, if you have two functions multiplied by each other, there's a rule if they are divided. So it will take the form of u divided by v. So if we do take the derivative of u over v, the quotient rule says that this is equal to the bottom times the derivative of the top, so u prime, minus the top times the derivative of the bottom. But this time, unlike the product rule, we have to divide it by v squared. So that is our quotient rule. Alright, so let's do a practice. So we are going to take the derivative of, we'll do x divided by cosine of x. So following this rule, and actually I should make the top a different color. There we go. So following this rule, we start with the bottom right here. So the bottom of this function is cosine of x. Actually, I'll write that in red. So cosine of x times the top, the derivative of the top, and the derivative of x is 1. So times 1 minus the top, x, times the derivative of the bottom. The derivative of cosine is negative sine. And then divide all of that by the square of the bottom. So cosine squared x. And to simplify this just a little bit, since there's a negative here and a negative here, they really become a plus, and we have cosine of x plus x sine of x divided by cosine squared of x. And there's really nothing obvious we can cancel at the moment. There may be some trigonometric rules that we could invoke to try to simplify it further, but for the purposes of this video, we're going to say that's our answer. Okay, so previously we have been taking the derivative of all these functions, but it hasn't actually been the full process of taking a derivative. We have the quotient rule, we have the product rule, we have all the rules we've gone over so far, but they actually haven't been complete. And I'm going to show you what I mean with this. So if we go the whole way back to one of our first rules, the derivative of x squared, or the derivative of x to an exponential. We said the rule was we just bring the 2 down and subtract 1, and then we get 2x, or 2x to the first power, which is just 2x. That's not entirely true. There is another part of it that we're going to start adding for every derivative we take, and that is this dx at the end. The dx becomes really important in future concepts of derivatives and really in calculus just moving forward. So we really need to start getting into the habit of including this dx at the end. And that dx really comes from the inside of the function. We're going to be introduced to something called a chain rule here very shortly, where this will be the derivative of something, but it won't be x. Because right now we know the derivative of x is 1. But it might not always be dx. We could have a dx squared at the end. We could have really any other function here. But everything we've done so far, this dx has just been 1, so we haven't been writing it. So let me give you an example of why this is important. So we are taking the derivative of functions, and previously everything we have has been with respect to x. And any function that we've been taking a derivative of has just had really an x inside of it. So for example, sine of x. We know that the derivative of that is cosine of x. But we haven't considered yet, sine of x squared, or sine of something other than x. So it's a function with more than just x in the center of it. And this is really where this dx on the end becomes important, because this is not equal to just cosine of x squared. Let me stress that again, this is not equal. The way we have to do this is we use the chain rule. So we turn this into terms of u. I know that letter has come up a lot, and it's annoying because you use u a lot, you use v a lot, and those letters can look very similar on the screen. But that's really just how calculus is taught normally, so I'm just going to stick with that notation. So to solve this, I'm going to rename this, or I'm going to change this function to actually be the derivative with respect to u. And I'm going to call the inside here u. So I'm going to say x squared equals u. Sorry, that's separate. So x squared equals u. And this is sine of u. Alright, so when we take the derivative, d over du of sine of u, we can follow the normal rule. So the derivative of sine is cosine. So cosine of u. And like I said before, we need to start adding this du at the end, or dx, or d, whatever it is that you're taking the derivative of. So this is just our normal rule of sine. We get cosine. But now what do we do with this u right here? So we set u equal to x squared, and we can plug it back in, but we have to plug it back into both places. So plugging it back in, we have this is equal to cosine of x squared, because we just plugged x squared back into u, because it's equal. And now we have to find du, so times du. So what is the derivative of x squared? Well, we know that. We just bring the 2 down and subtract 1 from the exponent, and we get 2x. So that's the missing piece here. When you have something on the inside, you have to multiply it by the derivative of the inside. So our final answer is 2x cosine of x squared. And interestingly, when you look up derivative tables, some derivative tables will use this x notation, which is like good for some purposes, not every purpose. But by and large, most derivative tables will have u in it. And honestly, same with integral tables. There's a lot of integral tables with u in it. So I know this is a very new concept. It's a little bit obscure or abstract if you haven't seen this before, but I promise you can get used to it very quickly. It just takes a little practice, and I'm going to start doing this from now on. I'm going to do another video after this just reviewing this, just giving you time to kind of get used to this new type of notation, this new addition to taking a derivative, but it will pay off dividends in the long run the more you get used to it. And this will come really well with practice. You really just have to practice it with a lot of problems. So I'm going to do that over the next couple videos, just show you examples and talk through the explanations and the solutions, and hopefully it will get a little easier as we go. And then after that, I'll slowly introduce a couple more rules that you really need to know this concept to be able to get through the rules. But this is the biggest, hardest concept in Calculus 1 to get past, is understanding this chain rule, this taking the derivative of both the function itself and the inside. Alright, I'll stop here and continue on in the next video.